Hey college algebra. In today's video we're going to be talking about interval notation and solving inequalities. To give you guys an idea of where we'll be ending up with this video, we'll be solving inequalities just like this one. So let's get started. Let's first start off with interval notation. Interval notation is extremely important to learn. You're going to be seeing a lot in your future math classes, and you're going to be seeing a lot in the outside world. It's super important. It just talks about a specific range of numbers. So just like I said, the first thing we need to understand about interval notation is intervals denote a range of numbers, and they look something like these. So the open brackets, these guys right here, represent an inequality that says less than or greater than. So when you see these guys right here, you're going to be looking at the open interval. Now the closed interval represents less than or equal to or greater than or equal to. So when you see these guys, you're going to use the closed brackets. Now let's look at this example right here. So we'll have all the numbers greater than 3, and so that's basically saying greater than 3. And so we're going to use the open interval right there. And less than or equal to 10. And we have that equal to right there. So that's going to be less than or equal to 10. And that's where we get that close bracket. So let's look at some examples where we'll use interval notation. So right here we have -3 is less than x, and x is less than 4. So since we're looking at just less thans here, we'll have the open interval, -3, comma 4. And on the graph, we're going to draw open circle at -3 and open circle at 4. These open circles represent less thans or greater thans. I'm going to draw a line connecting the two. So this line right here, this blue line, represents the range of numbers that x can be. So let's move on to one where it's a closed interval, or where we'll use a closed interval. So just like in an equation, we're going to divide by 2. And by doing this, you're going to get x by itself. So we'll get x is greater than or equal to -2. Cool. So let's put that into interval notation. This one's a little different because we don't have two sides to it, we just have one. But since it's greater than or equal to, we'll have -2 right here, comma, but x can be anything greater than -2. It can go off to 100, to 1,000,000, to quadrillion, just really big numbers, and so we're going to say infinity. I'll have the close band right there. Okay, so now let's put a -2 right here. And when we're looking at a closed interval, we're going to draw in our circles and draw an arrow all the way out to infinity. So the key thing here to remember is the less than or equal to's or the greater than or equal to's, you want to have a filled in circle. And with the less than or greater thans, you want to have an open circle on your number line. So now let's solve this first inequality, and just like in an equation, we're going to try to get x by itself. So here, we'll subtract 3, and we'll subtract 3 from this side, so we'll get -9 is less than 3x. Now we just divide by 3, and so we'll get -3 is less than x. Now if we're to put that in an interval notation, we have less than. So we'll have open like this, but x is greater than -3, so we'll have -3, comma infinity. Cool. All right, so what happens when you divide by a negative? Well, what's going to happen is your inequality is going to flip, and this is one of the most common mistakes we see in students, and is when they divide by a negative or multiply by a negative when looking at an inequality, and they forget to flip the sign. So let's go ahead and look at this example, and I'll show you guys. So right here, we're going to divide by -3, divide by -3. So what's going to happen is I have 2 is greater than x. And I'm hoping you guys saw that, and all I did was flipped that less than to greater than. So what this is saying now is x has to be less than anything under 2. And so we can write this as an inequality. And so x is less than anything under 2. So we'll have 2 over here. But x can be anything from -100, just really big numbers. So we'll have negative infinity this time. Negative infinity. Let me just erase that right quick. Negative infinity. Cool. Now let's look at this linear inequality. And this one's going to be a little different because we have one inequality right there, one inequality right there. So our first step for these is to break it up into 2 bits. So let's have -5 is less than or equal to 3 minus x. And we'll break it up so that 3 minus x is less than or equal to 5. Okay, so now we can solve both of them just like we would any other equation. So let's subtract the 3, subtract the 3. Okay, now we're left with this -1. Remember from that last slide, whenever we divide by negative, we flip our signs. So we'll have to divide by -1. We'll get so yeah, we flipped our signs. Perfect. And that's where we left off with that one. Now let's move on to this one to the right. So first, subtract by 3, subtract by 3. Okay, now we divide by that -1. Now let's combine the two. So then we'll have 8 is greater than or equal to x, and x is greater than or equal to -2. Okay, so let's put this into an interval notation. So when we do that, oh, before I move on to that, one thing I want to stress is you see how our carets are both pointing to the right. You guys got to make sure that both carets either point to the right or both carets are pointing to the left. Just like this one, how they're pointing over to the left. So make sure that we have them both pointing in the same direction. Okay. So anyways, back to where I was. Let's write this in interval notation. So the smaller number is always going to come first. And so since these are greater than or equal to's, we'll have -2, comma 8. And that'll be our interval. Okay. Okay, so let's solve this rational inequality. So nobody freak out. This is really pretty simple, and all we're going to do is separate it into 2 parts again. So we'll have 2 is less than or equal to 3x plus 2 all over 3. And then we'll have 3x plus 2 all over 3 is less than or equal to 5. Okay, we separated to 2 parts. Now what do we do about this rational bit? Well, it's easy. All we do is multiply both sides by 3. So by doing that, we get 6 is less than or equal to 3x plus 2, because these 3's are going to cancel out. All right, now we just solve it like we would any other inequality. So subtract the 2, subtract the 2, we'll get 4 is less than or equal to 3x, divide by 3, divide by 3. Okay, cool. So we got x by itself. Perfect. Now let's move on to the other one. And this one, I'm going to pause the video and come up with a solution at the end, and then we'll come back together to write an interval. So after I got done solving for x, I got x is less than or equal to 13 over 3. I was hoping you guys got the same thing too. So now let's put this into interval notation. By doing this, we put the small number first. So closed. So yeah, we have x is greater than or equal to 4/3. So we write as this also, less than or equal to x, which is less than or equal to 13 over 3. So for this inequality, we're not going to solve in this video. I just wanted to show you guys this inequality to give you a heads up on what we'll be talking about later on. So this might be Monday at the end of class, or we might have it in a video on Monday. I think it's just a good heads up. Maybe you guys can Google search it if you're interested. So what I want you guys to do once you're done watching this video is try solving these two problems. Bring them into class Monday. So you'll have these two problems and the 3 problems from the complex video. Yeah, and I hope this video was enough practice. Please come ready with questions if you have any. I'll see you guys Monday.